Welcome, my dear learners, to today's exciting episode on this very channel. In today's lesson, we shall be looking at a new topic altogether. This topic is common to students at the JHS level, SHS level, and even beyond. So in this lesson, we shall be looking at sets, S-E-T, sets. Way back in JHS, when they asked us to explain or define sets, what we normally say is that a set is a collection of objects of the same kind. That is a very good answer. But in this lesson, we are going to refine this definition. So when we talk about set, it's an unordered collection of a well-defined object. An unordered collection of a well-defined object. Now the keywords in this definition are unordered and then well defined. So let's look at these words in the definition. Now, unordered. Now, when we talk about unordered collection of objects, it means that the arrangement of the elements or objects within the set doesn't matter. The arrangement of the members or elements within the set doesn't matter. So when you have a set which contains, let's say, set A, which contains the elements 1, 2, and then 3. So with these same sets, someone can also decide to write this set as 2, 1, and then 3 to suit his or her preference. I can also decide to write set A as 3, 2, and then 1. The order of arrangement of the element within the set doesn't matter. But the most important thing is that those elements within the set must be intact, or those elements within the set must all be present. So that is the unordered collection. Similarly, when you have, let's say, set B, which contains the elements A, B, and then C. This set B is the same as B, A, and then C. It's also the same as C, B, and then A. The most important thing is that those elements within the set must all be present. They must be intact. If that happens, the order of arrangement of the element within the set doesn't matter. That is the meaning of the unordered. Now let's look at the well-defined. Well-defined. Now when we talk about the well-defined object, now a well-defined object simply means that each element or member within the set has a unique property that determines its inclusion or exclusion within the set. So when you have, let's say, a set A, which contains what? Even numbers. Now we know that even numbers are numbers that are divisible by 2 without any remainder. So when you have any number that cannot be divided by 2 exactly, that number cannot be part of these numbers. So you realize that 3 cannot be part of these numbers, 5 cannot be part of these numbers, 7 cannot be part of these numbers, and so on. So in listing these elements, we are going to start with what? 2, 4, 6, 8, 10, and so on. So this means that we have set a rule or a criterion that is guiding us in our selection. So any element or member that goes contrary to the rules or criterion that we have set refuses to be part of this set. Therefore, any element that you see in this set is uniquely defined based on the rules or criteria that we have set. Now that we understand the definition of this set, let's look at examples of sets based on the definition that we have given. So these are very few examples of sets. So we can talk of a set of even numbers, a set of letters of the alphabet, a set of days of the week. You can also talk of a set of what months of the year. And when you are listing these elements, I believe you are not going to add letters to numbers or numbers to letters, days to letters, and then days to numbers based on these definitions that we have given. Good. Now, let's take the first one. We have what? A set of what? Even numbers. So if we are to list the element of this set A, we are going to get 2, 4, 6, 8, 10, and so now each object within the set is called an element. So we have elements. Each object within the set is called an element or what? A member. So we can see that 2 is an element of set A, 4 is a member of what? Set A. So those items or objects within the set are called element or member. So you can see that 4 is a member of what? Set A. This member of can be written symbolically as this. So you can see that 2 is a member of what? Set A. We can also see that 4 is also a member of what? Set A. 10 is also a member of what? Set A. Now, whereas an element is not a member of that set, can also be written symbolically. So we can see that 3 is not a member of what? Set A. We can also see that 5 is not a member of set A. So this symbol means that not a member of, does not belongs to, not an element of. And this symbol means it's a member of, it's an element of, belongs to. Now, a set is represented with capital letters. You realize that anytime that I'm writing set, I start with what? A capital letter. You can write a set to be set A, then we have 1, 2, 3, 4, and so on. The set is represented with what? Capital letters. So instead of this small a, I'm going to write what? Capital A. Now the next thing that we shall be looking in our next lesson is ways of describing or representing sets. So we are looking at ways of describing or representing sets. With the ways of describing or representing sets, we are going to look at 4 main ways. And we are going to look at the first one, which is what? The word description for word description. We shall also be looking at the listing method or the roster method. We shall also be looking at the set builder notation. And then lastly, using what? The Venn diagram. So these are the very 4 ways through which we can describe or represent sets. So we are going to take one after the other. So starting with the word description form. The word description form. Now with the word description form, we are just going to use words or sentences to describe the set. We are going to use words or sentences to describe a given set. So an example is, so we have a set A which contains even numbers between 2 and then 20. So we realize that we have used words and sentences to describe set A. Another example is, so we have also used words or sentences to describe set A. We are saying that D is a set of prime numbers between 1 and then 10. So when we talk about the word description form, it means using words or sentences to describe set or a given set. Now let's look at the listing method. Now the listing method, now with this method, what we are going to do is that we are going to list the element or members within the set. We are going to list the element or members within that particular set. So with the first example, which is A is a set of even numbers between 2 and then 20, under the word description, we can use the listing method to describe that particular set. So we can say that A, we have we are talking about even numbers between 2 and then 20. So we have 4, 6, 8, 10, 12, 14, 16, and then 18. So we have listed the element within the set. That is under the listing method. Now we can also describe set B by means of listing the element within set B. So set B, we have D is a set of prime numbers between 1 and then 10. So under the listing method, we are going to list the element of this particular set. So we are going to have 2, 3, 5, and then 7. So under the listing method, what it means that we are going to list the element within the set. That is the listing method. Now let's look at the third one, which is the set builder notation. Now with the set builder notation, what we are going to do is that we are going to use the properties of the element within the set to describe them. So an example is the same example under the word description. We said that A is a set of even numbers between 2 and then 20. We can use the set builder notation to describe this set. So this is how we are going to go about it. We have A, X is such that X is greater than 2 and D same X is less than 20, where X is even. So we have used the set builder notation to describe this particular set. So this is how it is being read. X is such that X is greater than 2 and this same X is less than 20, where X is even. So it means that all those elements that we are going to list, we have used X to stand for those even numbers that we are going to list between this range. Good. Now with the same word description, we had B is a set of prime numbers between 1 and then 10. So we can use the set builder notation to describe that particular set. So we are going to have X, this forest rise the same as that X is greater than 1 and this same X is less than 10, where X is 9. So this will tell you that all those elements that we are going to list, they should be prime numbers, but they must be between 1 and then 10. So X is said that X is greater than 1, but this X is less than 10. Go. So this is the set builder notation. Good. Now let's look at the last one, which is what? Using the Venn diagram. The Venn diagram. So with the Venn diagram, let's take it that you have the universal set, which contains the elements 1, 2, 3, 4, 5, 6, and then 7. And then you have a subset of this universal set, which contains the element 2, 4, 6. And then you have another subset of the universal set, which contains the element 2, 3, 5. Now we can use the Venn diagram to represent this set or describe this set. So this is how we are going to go about it. We know that with the Venn diagram, we draw our rectangular box, and then on top we have our universal set. So we are going to have 1, 2, up to where? 7. Now the number of circles that we are going to draw within the Venn diagram depends on the number of subsets that we have. So we have how many subsets? We have 2. This means that we are going to draw 2 circles. But before we draw our circles, we have to check and see if you have an intersecting number, a number that belongs to these 2 subsets. We have 2 and then 2. So under the intersection, we have what? 2. So this means that this circle that we are going to draw, they are going to intersect. Good. So we are going to have 2 circles all intersecting. One for set A and then one for set B. So after that, the first region that you are supposed to represent your element is what? The intersection. So we have what? 2. And then after that, we move on to A. So we have 4 and then what? 6. We have 2, 4, 6, 2, 4, 6. Then we move on to subset B. We have 2, 3, 5. We have 2, 3, and then 5. And then we have a number which does not belong to set A and then set B, but it is part of what? The universal set. So we represent it outside the 2 circles. Good. So it means that we have used what? The Venn diagram to describe or represent this particular set. So we have learned that we have 4 ways of representing sets using what? The word description form, where words or sentences are used to describe the set. We have the listing method, where the elements or members within the set are listed. And then we have the set builder notation, and then we have what? The Venn diagram. This brings us to the end of today's lesson. See you tomorrow. Bye bye.